Hello, everyone. Welcome back to AI models. Today, we are going to talk about linear regression. It is the simplest form of AI model, which is a very good starting point if you have to start learning about AI. I'm going to try to explain it to you with as much as little mathematical jargon as possible in simple language. Okay. So, what is linear regression? It is a statistical method. Basically, what are we using AI for? Forget about just linear regression. AI is in many industries, AI is used for predictions, right? Like given X, what will be the value of Y? Given money spent on advertisements, what will be the future sales? So that we can make some informed decisions. Like given this trend, what will be the value of sales or what will be the value of a stock in a near future. That is what, in most cases, AI is used for. Of course, you choose any industry, there is AI applicability, but it all started with that to make predictions, right? So it helps us understand linear regression models, help us understand how if one variable changes, how the other dependent variable will change accordingly. So you will have two sets of data points. So let's say if you study more, the number of hours you put in and the grade that you get. Of course, given that when you're putting the number of hours, you're actually studying, right? But that's just the assumption, okay? How much grade that you get. So linear regression tries to find a straight line, like a linear relationship that best fits these data points, which means which best connects these data points or equally divide them. Okay. This line then can be used to make predictions. Well, actually, when we say that this line, it's not actually you are physically drawing a line. This is for visualization purposes. We are going to see an actual program in Python, written in Python, that will do some linear regression and predict some values for us, or how to do it in real life, how it is done. Okay. The graph, the plotting, everything is for visualization purposes. What are the steps involved if you have to do linear regression? First of all, define what the problem is. Like, what are you trying to predict? Okay. So let's say, given the time and the population, what would be the traffic, right? Or given the population, what the thing about linear regression is it just tries to find with one independent and one dependent. In later models, we'll see how to use multiple regression or polyregression, but this is just we are restricting one independent variable and one dependent variable, like the variable which is depending on the value of the independent variable. Gather the data, relevant data. So let's say if you want to predict sales. So sales, it's affected by advertising. One of the factors, right, is affected by advertising. Or let's say it's also affected by price. So you choose any one. So say if the price is X, what will be the sales? And if the price is Y, what are the sales? So you gather these data across a different time frame, right? Let's say the past year, if the prices have changed, past multiple years, what was the price and what was the sale value? You gather the data. In most cases, the data is in CSV files, or in some cases, I haven't done it, but it could be you could read it from directly from a DB and load it into some array and then try to predict it. So you collect the data, relevant data, obviously, explore the data, analyze and visualize the data to understand its characteristics. You can use different diagrams, scatter plots, histograms, and other to find the relationship between the two. Then split the data. So now you have, let's say if you have 10 years of data of whatever independent and dependent variable, you split it. 5 years, let's say you train your model on the 5 years data, and then you test your model on the remaining 5 years data. Like you validate your model. Okay. Now there is a lot of detail into that, like how much how much data you should use for training the model. If you use, let's say you have 10 years data and you use all 10 years data, and then you test it again on the same 10 years data, this is overfitting. It's an overfitting problem. Okay. So you have to be very tactful in dividing your data between training your model and um, what do you call it? Testing your model. Then choose a model, decide on the type of linear regression. So it's simple linear regression, or you have multiple linear regressions when you have more than one um, variables which are affecting. Today, we are talking about just one-on-one. Define the objective, what you want of the, find out the errors, least squares errors. This involves then you train the model on the data. We'll see how do we train the model, and you can use make predictions, evaluate the model, whether it predicted. So let's say, for example, you had 10 years data, right? You used first 5 years data to train the model. Then give the 6 years data, which you already have, to the model, to the regression, and see what it predicts. The difference that is there, that's the error, right? So let's say, for example, in the 6th year, your advertisement you spent on advertisement was, say, 100,000, and your sales was 150,000. You give this 100,000 to your model, put it into your model, and see what the model predicts. So let's say the model predicted 130,000, but actually your sales were 150. So that difference 20,000 is the error. Okay. That is how you evaluate the model. And that is called as mean squared error or R squared error. But basically it's you evaluate, you give the known data, like the data for which you're already sure about it, right? You know the values. And then accordingly, you readjust the models, iterate and define until the error is minimum. Okay, until the error is minimum. So it's highly unlikely that your errors would be zero. If your error is zero, you haven't trained the model properly, or you have overfitted the model. No AI model, as of now, can predict exactly what is happening, right? You can always work on getting it as close to real data as possible, as minimum error as possible. This is how an AI model looks like, right? So you plot the point. This is just for visualization purposes. Again, best fit line. You draw a line which best fits all the data points. Okay. You have independent variable and then you have dependent. So this could be advertising, for example, this could be the money that you spent on advertising, and this could be the sales. Okay? And here, see, you have different data points. You choose, see, if you draw a line here, most of the points would be above. Choose a line here, most of the lines would be the below. So you choose a best fit lines, which is almost equal. Okay. So see here, it's the least, the difference between what the line will predict and the actual value. This is because these are the actual values. This is difference between what the line will predict and the actual values. Okay. So this is it. Let's see this in action. I'm going to use Jupyter Notebooks, which is here. Okay, it's directly online, which shows the demo of linear regression. This is using Python. So you use NumPy and Matplotlib. This is for plotting all these things that you see. And you use sklearn linear model. Okay, you're importing. So you import all these. So how do you do it? Just write this, just run in the cell. You execute the cell. Now see here, I'm just creating some sample data, okay? It's not real data, but you could also have X and Y come from a CSV file. So I'm just saying X is these, when X is 5, Y is 5. When X is 15, Y is 20. When X is 25, Y is 14. So just defining a relationship. This is just a sample data. So I run this. You use the plotter to plot. Okay, this would be a little different because I added more data points. So see here the two extreme end data points. So the model changed a little bit. You just visualize it. Now you use the linear regression model, which is available from sklearn, this library, and then you fit the model. Okay, find the slope and intercept. The slope of the line is this, intercept is this. Intercept is where the line meets the x-axis. Okay? Now you predict. What I'm trying to do is, see, I have data until 65. So I'm predicting when x is 90, what would be the value of y? Okay, so when new x is 90, what would be the value of y? Let's see. Where did it go? Sorry. For 90, here. So when the value of x is 90, predicted value is 54 point blah, blah, blah. Okay, and then you try to plot it. And this is how you see the best fit line. Okay, so basically this is this part is for visualization, but basically what we were using for is this part, that given a new value of the independent variable, what would be the value of the dependent variable? Okay. This is in very, very, very simple terms how in real life you're going to use linear models. This is just for learning purposes. In later on coming lectures, we're going to see how to use more complex models. Okay, neural networks, poly regressions, and all this kind of stuff. This is just to get your hands or familiarized with the concept of what it is and how to use the models. Okay, so this is how you're going to use it for in real life models. Go ahead, read some extra materials on linear regression and all, and have your understanding clear. And see you all again in the next lecture with some other models. Thank you for your time.